The problem statement from GATE Physics 2020 reads as follows. Which one of the following is the correct binary equivalent of the hexadecimal F6C? We are given 4 options. This is a multiple choice question with only one correct answer, and we are required to find the correct one. And the question asks, we need to convert this hexadecimal number F6C to its binary equivalent. So binary and hexadecimal are part of what we call as number systems. So there are different number systems that we encounter. Decimal is the most common one. We have seen this while growing up, and the symbols that are used in decimal number system are 0 to 9, 0, 1, 2, 3, 4 up to 9. And mathematically this is expressed, this has a base 10. So we'll see that. For instance, you want to write, let's say, number 29. So 29, this means the base is 10. It's expressed like this. And the most salient feature is that it's humane, means we have seen it around. It's around us all the time. However, machines required a much simpler number system, and thus binary number system was evolved. And the biggest feature of it is the simplicity. It just needs 2 symbols. So 0 symbol usually means off or low, and 1 symbol usually means on or high. That depends on the nomenclature. And of course this uses base 2 because there are 2 different symbols. Here there are, in decimal there are 10 different symbols and the base is 10. However, what happened was that, let's say if we were to express 255 in decimal, let's say in binary, so we'll learn how to convert, but just this comes out to be 8 times 1. So what it does is that, you see, this simple, this 3 digits took 8 symbols. So what again, a different number system was evolved, that was hexadecimal, that was primarily used to compress the binary. So it uses 16 different symbols, since the base is 16 and the symbols are 0 to 9, just like the decimal one, plus 6 other symbols, capital A to capital F. So capital A in hexadecimal is nothing but number 10 in decimal. Similarly, B in hexadecimal is nothing but the number 11 in decimal, and so on. The symbol F in hexadecimal is nothing but the number 15 in decimal. Similarly, there was one more number system called octal. You might see it sometimes. The base is 8 and the symbols used are 0 to 7. Now, for our interest, the most important thing is how do we convert one number system to another. So let's say you are given the number 1C in hexadecimal, and you want to know what is this number in binary, right? So there are 2. So the first way of doing this is just to convert whatever this number is into decimal. So it's very simple to do. The way we do it is C times 16 to the power 0, the first term, plus 1 into 16 to the power 1. So this will come out to be 1 into 16 plus, we know C is 12. C is 12 plus 16 to the power 0 is 1. So this will come out to be 28. Now this is in decimal. So what we have obtained, we have gone to an intermediate step. This is 28 in decimal, and now we just need to convert the decimal to binary. So I'm using the first approach here, right? So how do we convert the decimal to a binary? You simply take the LCM. So 14, and you write the remainder here. So remainder is 0. Again 2 7, remainder is 0. 2 3s are 6, remainder is 1, and 2 1s are 2, remainder is 1. And the way to write the binary is we write from here to here. So the binary number would be, for this, the binary number would be 1 1 1 0 0. So this is the way we write the, we have converted now 1C, which was in hexadecimal, to this using an intermediary decimal number, which came out to be 28. Now this is a lengthy approach. These are very small numbers. However, in the computer scientists acquire huge amount of let's say these symbols. So there might be like the symbol can be F. It will be a nightmare to convert it into decimal and then convert it back into binary. So what we do is that we use a trick. So the trick to convert binary to hexadecimal, just remember that 4 symbols of binary is 1 symbol of hexadecimal. So what I mean to say is that let's say the number given to us is this. F6C in hexadecimal, and we need to find what is this in binary. We know that one symbol of hexadecimal, I'm writing it as hex, is equivalent to 4 symbols of binary. So let's do that. So let's just consider the first symbol here, C. So C in hexadecimal is nothing. We know that this is 12 in decimal, and 12 in decimal is nothing but is 1100 in binary. How do you convert? You again use the LCM approach. So you can convert 12 to binary, it comes out to be 1100. Second, 6 in hexadecimal. 6 in hexadecimal will be nothing but 6 in binary, 6 in decimal. This will be 6 in decimal, and 6 in decimal can be written as 0110 in binary. The final symbol was F. F in hexadecimal is nothing but 15 in decimal, which can be written as 1111 in binary. Now, so this row that you see is hex, the middle row is decimal, and the bottom row you see is binary. So, and I told you that one symbol, so C is one symbol, and we have created 4 symbols for binary. Then the symbol is 1100. Similarly, the symbol 6 in hexadecimal is written as not 110. Note, there is a 0 added because we have to have 4 symbols. So it will be 0110, and similarly F in hexadecimal has been converted to 1111 in binary. So I can simply write F6C, we have converted it to 1100. 6 we got 0110, F we got 1111. So this is the final number in binary on the bottom of your screen, while this was the number in hexadecimal. I repeat, 6 we converted to 1100, C we converted to 1100, 6 we converted to 0110. The extra 0 is there, so there have to be 4 symbols. Note that this is the formula or the trick that we had used, right? And finally F in hexadecimal is nothing but 1111. So our option is 1111, 0110, 1100, which is option B. Thank you for listening.